Hi folks, welcome back to the Trig equations videos. Exciting times here. We're going to find some approximate solutions. As always, there are downloadable notes and there's also a worksheet that you can do to practice. Just check the video description below. So far we've been able to solve equations like this. Sine x equals, say, root 3 over 2. There were very specific values in the table that we could find exact angles that corresponded to them. But we often have trig equations which do not correspond to a special reference angle. So they might take the form trig x, which could be sine, cosine, or tangent, equals some constant. So here's an example. Cosine x is negative 0.6. It's not in the table. But our technique for solving doesn't change. We'll just need the calculator's help to find the reference angle. So let's try one. Cosine x equals negative 0.6, and we're only solving for the very first revolution, from 0 to 360. We're working in degrees. Good to notice. Okay, so we find theta ref. Normally we go to the table and we go, okay, where is cosine 0.6? It doesn't seem to be there. We got trouble. You could use the table to help you estimate, but you're not going to find the exact value. Here's what we're going to do instead. We'll just do the inverse cosine of, and just like before, we'll forget about whether it's positive or negative for now, for the reference angle. So the inverse cosine of 0.6, sometimes written arc cos. So inverse cos of 0.6. Let me go to my calculator and get that. Oh, we were in degrees. I better make sure I'm in degrees. That's looking good. Inverse cosine of 0.6. Here the calculator is going to tell me what the corresponding angle is. If I have a cosine of 0.6, the angle should be about 53.1 degrees. Now notice that the title of the video was Approximate Solutions. It's not exactly 53.1 degrees, but it's around there, so we're approximating. Okay, now everything follows the exact same way it did in the other videos. We need to use Astc. So let's see now. We've got a cosine that's negative. Where's cosine negative? It's negative right here. And right here, it's positive in 1 and 4, negative in 2 and 3. Let's draw these angles. So they're happening in quadrants 3 and 4. And a reference angle is always measured with the x-axis. Now we need to figure out what these are in standard position. So this first one I would think of as 180 less 53.1 degrees. Okay, and if we work that out to one decimal place, we'll get 126.9. For the other one, I'd think of it as 180 plus 53.1 degrees. Okay, and that gives us 233.1. And you might say, I don't believe you. I don't think those angles are any good. Well, let's just find out. Throw them back in your calculator. Cosine of 126.9. Oh, geez, I hope it's negative 0.6. Yes, it is, but there's a little rounding error. And that's because we rounded our angle. It's an approximate solution. If we do the same thing with the other solution, 233.1, again, negative 0.6. So we must have done this properly. We found the angles that give us a cosine of negative 0.6. The rest of the examples here are similar. So if I want a tan of 0.7, number one, I find theta ref. Okay, go through. It doesn't have 0.7, so I just go inverse tan of 0.7. And it's going to give me, I'll use the roughly equal symbol, 34.99. Oh, but we should have been paying attention here. This is in radians. So let me change my calculator so that it's in radian mode. We'll try that again. Inverse tan of 0.7. In radians, that's 0.611. Okay. If we had been doing it in degrees, it would have been about 35 degrees. Now, let's figure out what quadrants we're in. Astc. Tangent is positive in quadrants 1 and 3. Let's go and sketch. Okay, so this is an angle of 0.611. And this is an angle of 0.611. The first one's easy to know what it is in standard position. It's 0.611. That much of a radius of a circle. So 0.611 radians. The next one is pi plus 0.611. And we're going to need an approximate solution to this, or an approximate value. So pi plus 0.611 gives us 3.73-ish. 753 rather. Okay, there we are in radians. One more. So again, we're working in radians. We really should have noticed that right off the bat in the last one. Theta ref. It's not in the table. There's no 0.3. So you're going to go inverse sine of, again, only look at the positive value. So inverse sine of 0.3. Let's figure out what that angle is in radians. And it tells me an angle of 0.305 has a sine of 0.3. Okay, step 2, Astc. And here we've got a negative sign. So sine is negative here and here. Quadrants 3 and 4. Let's sketch 0.305. And your sketch does not need to be a work of art. If you're not quite sure exactly how big 0.305 is, that's okay. It's a pretty small angle. But whether you draw it big or small, the process is going to be the same. This first one is pi plus 0.305. Okay, let's figure out what that is as a decimal approximation. 0.345. 3.45 rather. Okay, the other one, it would be a full revolution. Take away that 0.305. So 2 pi minus 0.305. And we get 5.98. So nothing has changed with our steps. It's just when it's not in the table, we need the calculator's help for the reference angle. If we're not quite sure, we can always check our answer. Let me try that one, 5.98. Really does give us a sine of negative 0.3 with a little rounding error. Okay, the next video we're going to look at is about reciprocal ratios, which is cosecant, secant, and cotangent. But these are the basics that we've dealt with so far. We've been able to deal with sine, cosine, and tangent in the first revolution, both in approximate and exact solutions, and working in degrees and radian measures. That's pretty good. I'll see you on the next one.